Hello all AI enthusiasts. So this is the original AlexNet paper. We all have used AlexNet somewhere in our computer vision or CNN. So I thought of discussing this paper with everyone. So let's get started. So the background of this paper is it was published in 2012. It was first large deep convolutional neural network. It was used in 2012 ImageNet challenge. So ImageNet dataset was published in 2010. Original dataset has 15 million images and 22k classes, but the dataset used in challenge is a subset, 1.2 million images with 1000 classes. And this neural network has 8 layers, out of which 5 are convolutional layers, 2 are fully connected, and 1000 software. It has some unique features. Few of them were adopted from the latest research of that time, like dropout and ReLU. They have also used local response normalization, overlapping pool, and multiple. So background of ImageNet dataset is it was one of the large dataset which was published. Before that, mostly datasets were very small. Cypher and other datasets were used. For CNN, the background is CNN generally has very few connections and very few parameters, but the problem with CNN is it has very high computation cost and training cost. And AlexNet unique thing was that was one of the largest neural network that was trained during that time. By neural network I mean convolutional neural network. And it was used for 2010 and 2012 ImageNet dataset. It also used highly optimized GPU implementation. So it has a very interesting code for GPU parallelization. You can check out the code on GitHub also. So dataset uses ImageNet dataset we have already discussed, and they had to report top 1 and top 5 error. So top 5 error rate is the fraction of test images for which the correct label is not among the top 5 label considered most probable by the model. And they had cropped the image from the central position into a 256 cross 256 patch, and they did not use any other pre-processing apart from that. Well, the architecture we have already discussed, 8 layered, 5 con, fully connected. Then ReLU was used. So ReLU has multiple benefits. One is it is very fast to train as compared to other activation functions like TANH, which was mostly used during that time. And now we also know that it is also beneficial in managing gradient problems. So this image shows the training of ReLU versus TANH. See, ReLU is converging very much faster in 5 to 6 epochs compared to TANH. Then they have used multiple GPU and cross parallelization of GPU because that time computation power was very less. So they had to do this to train their network. Then they have used this local response normalization. So another thing about ReLU is they don't need input normalization. And by local response is also like a bright normalization. They observe that top 1 and top 5 error rates reduced. And these are some hyperparameters they have used. You can local response normalization. Okay, another unique feature is they used overlapping pool. So they have used max pool, but overlapping pool. So generally we use, if we are using a 3 cross 3 pool, we will use a stride of 3, right? But they have used a 3 cross 3 pool with a stride of 2. So that's why there's an overlap. So this is the overall architecture. They have 8 layers, 5 con and 3 fully connected layers. They have used max pooling between some con layers, and the input size is 224 cross 224 cross 3. So this is the summary of the layers. So input is 224 cross 3. So first layer has 11 cross 3 filter, and with a stride of 4 and 96 filter. Then a 3 cross 3 pooling layer with 2 stride. So similarly second layer is 5 cross 5 cross 96 filter because 96 channels were incorporated because of first layer, and stride of 1, and again 3 cross 3 cross 2, and finally a softmax layer with 1000 classes. Well, so now overfitting. So because they had used a large neural network, so they needed overfitting. So they have used 2 overfitting techniques. One is definitely data augmentation, is the easiest method to reduce overfitting. In data augmentation, they have used 2 tactics: image translation and horizontal reflection. So image translation is from the cropped image 256 cross 256. They have taken patches of 224 cross 224, and they have also created a horizontal reflection of these patches. Thus, they have increased the image number by a factor of 2048. And they have done a PCA for altering the RGB intensities. So this has also improved the accuracy by reducing top 1% error, and this has also made this model invariant to the changes in intensities. Well, dropout is used in 2 fully connected layers and with a probability of 0.5. So for learning they have used SD, batch size 128, momentum 0.9, decay of 10 to the power minus 5 into 5. And they have used various initialization techniques also for so which has helped in faster training. So you can go through this some question, and then for biases also they have used some. Well, the result is pretty obvious. So this actually won 2012 competition, and if you see, so this is the result for 2010. So in 2010, if you see other models, they have performed 28, 25, and it is 17. And in 2012, if you see, so other models have performed 26.2, and this is 15.3 and 16.4, and basically 5 CNN and 7 they have taken averaging over 5 CNN and 7 CNN. So this is the result with single CNN. Well, they have shown how their models qualitative analysis. So if you see various pictures, so they have shown the top 5 top 5 labels for various pictures, and they show that these are all reasonable. There is nothing very drastic or unreasonable labels. And the right hand image they have shown, this is that first column shows the test images, and the other column shows the train images which are very close to the test images. Well, their conclusion is that a larger and deep neural network is capable of achieving better results, and they have not used any unsupervised pre-training, but it also might help in increasing the accuracy. So well, after this, there were a lot of new research papers that has come: Inception, GoogleNet, ResNet, which is most popular now. So we will discuss other papers, and we'll also see the comparison in all these papers. Thank you so much.